What's up, Algebra 1? We have been talking about correlation. At least we started talking about correlation today. Correlation is the concept of how two things are tied together, how two ideas are related. And so we're going to actually look at several different tables of data. And we're going to think about whether or not we would call them linear or not. Because when we're trying to come up with a linear regression equation, then that means we believe that the data is behaving linearly, which means they seem to form a line trending up if it's positive, or trending down if it's negative. And so I thought maybe we'd start off by kind of sketching a picture of the points for this one in particular. So the very first one's talking about like how much profit somebody made over time. And so we're trying to see, is this behaving linearly? And so if you notice, I started my graph where we are really utilizing the origin. We're starting at that far left corner, if you will. And one thing that we probably didn't do as much in class, we'll definitely do tomorrow, is whenever you're talking about years, we won't put them in the calculator exactly as the given year. So for example, like 2011, that's kind of like your initial year. Okay, 2011. That's like your 0 year. And then 2012, 2013, 2014, 2015, 2016, and so forth. So we're kind of treating those like 1 and 2 and 3 because they represent being really close to the origin. And really, these are years since that first one. So 2012 is 1 year after that initial year, or 2016, well, that's 5 years since the first year. And so let's just kind of plot these points and kind of see what they would look like. So that initial year, 2011, they made about $50,000. And then for 2012, they had made it to like 75,000. So far, so good. And then for 2013, it's like they went way up. They made it all the way to 150. It's pretty good. And then 2014, not bad. I mean, they did decline just a little bit, kind of estimating that point. 2015, another good year. We're getting closer to 200,000, if you will. And then 2016 was even better, slightly above that, maybe somewhere up here. And so what we call this type of graph is a scatter plot. A scatter plot represents isolated points, discrete points, not continuous, but discrete, that seem to be trending up. And not exactly, they're not perfectly in a line, but I mean, you can kind of draw a line of best fit and it hits a majority of those points for the most part. And so we can kind of say, okay, I don't know if this formula we're about to come up with would predict it exactly, but I'm sure it would kind of get us in the ballpark if we were trying to predict like some value in the future, 2020 or 2025 or something like that. So I'm going to go to my calculator. And I've already put in the values, and what I'd really want you to pay close attention to is that I did not use the years. I used how many years it had been since that first year. And so I'm going to go to Stat. I want to go right to Calculate, and number 4, I want to run linear regression, meaning you want an equation that you think fits these data points, and you believe it behaves linearly. So when we're looking at our equation here, there are some important things to take away from it. First of all, the A and the B value, this is what's going to help me write my equation. So it looks like, I'm going to pause the video for Tom and write. All right, so I'm back, and so I have taken a moment to look at my equation, y equals ax plus b, and I have looked at my A value, looked at my B value, and basically substituted them in to that top equation. So I do need a y and I do need x as a part of my answer choice, but that's kind of what I've turned into my answer here. Y equals 34,571, some rounding there with x, plus the 50,000 value, rounded as well. So the other value that was important in the calculator is this R value, this 0.957. That value really tells me how close all of those points are to my line of best fit. Meaning like how accurate is this equation? Are these points anywhere close to this equation? If I was to plug in 4, how close would I get to 195,000, for example? And so I think of 0.957 as kind of like 95%. So it's accurate about 95% of the time, and that's pretty good. 19 out of 20 isn't bad. But we're going to keep looking at this value and see in other questions how when that number is smaller, these points do not seem to fall on the line very well. So let's look at another problem. So now we're going to look at this second table of values, still talking about years, profit made in each year. And so again, just to kind of show our first year to represent 2011. So I'm going to input that value in the calculator as 0. I don't want the 2011. I don't want to be way down the axis. So I may change that value numerically in the calculator so that it's just a smaller input value. So this would be 1 year later, 2 years later, 3, 4, and 5. Okay, so we know that that 0 is 2011. So here's 1 year later, 2 years later, 3, 4, 5, and 6. And so this would basically represent years since, and that first year is 2011. Okay, and again, that would be this value at the very beginning when x is 0, essentially. So let's see how close these are to being in a line. You have 100,000 exactly for the initial value, and then 1 year later you're at like 85,000, and then the second year you're back at 91,000, and then the third year you're at 82,000, and then that fourth year you're just a little below 80,000, 79.5, and then fifth year, 2016, you're at like 74. Okay, so again, if you're thinking, well, is this linear? You may say, well, no, it's not in a perfect line, and I would agree with you. It's not in a perfect line, but if you try to draw a line, you're going to really hit a majority of those points or get fairly close to those points. So this is behaving linearly. It's not perfectly linear, but it still has linear tendencies. And so let's go to the calculator. And please notice that I'm not using the years. I am starting with 0 for 2011, and those other numbers represent years since 2011. Stat, go over once to calculate, number 4. And now I want to calculate exactly what my equation is. So I'm going to pause the video, make it easier on myself. So I'm back. So I am again taking these values, looking at my model, y equals ax plus b, and then substituting a's value and b's value so that I still have y equals a number with x and a number with so let's kind of look and see what that equation looks like when you have recorded on your paper. And then again, this correlation coefficient. So as we notice, first of all, this number is negative, and that's because my line of best fit is trending down. And it's still fairly strong. I mean, this is like 91% accurate, if you will. So this is another strong negative correlation. It's slowly getting further away. These points are getting farther and farther from that line. And it's because the trend kind of bucked in here. It went down, then it went up, then it went down, then it went down, down. So it's still linear going negative. However, those small changes in it kind of throws off the way you can predict the future, or at least how well you can rely on your formula to be accurate. So let's look at one more. So I went ahead and sketched a little graph here so that we can kind of plot some of the points. And this one's not about profit anymore. This is more about like height of a ball or height of a rock or something over time. And so it looks like at 0 time on the clock, it's already 5 seconds or 5 feet off the ground. 1 second later, you're at 21 feet. Then you're at 34 up here. And then now you're going down to 31. Again, it's an estimation. 4 would be 18. So that's somewhere right there. And then 5, you're all the way back down to 3. So you may be looking at this and saying, this does not feel linear. And I would agree with you. This is more quadratic because it seems to be going up and back down. Well, what does that mean for when we do a linear correlation? So I went ahead and put these values in the calculator, and again, they're not giving us years, so that's kind of a rule for years specifically that I don't use those values exactly. But I've put those values in the calculator. Let's go to Stat. Let's move to Calculate. Let's run number 4. And let's kind of see what our equation looks like. So a few things. I'm going to pause the video. All right, so now I have run my regression, and I am now putting those values estimated on my paper. And the first thing that I would say is they estimate that starting value to be roughly 20. So that'd be somewhere over here. And then it's going down just a little bit. So we're going to talk about graphing lines later. That's really not what this section is really about. It's more about using the calculator to make that equation. But we're talking about whether or not the model is good or not, and that's what this R value kind of tells you. And if you notice 0.09, I mean, that is roughly 10%. And I don't think you would use something if it was only accurate 10% of the time. That means that most of the time, my points are way off from my equation. Meaning if you plug in 2, you're probably not going to get anything near 34. And that's kind of what I'm saying. That value kind of tells us how much we can trust that equation to model that data accurately. So I'm just going to do 3 on the video. Hopefully you'll have these examples or these ideas tomorrow in class. And then we'll go ahead and talk about 4, 5, and 6 in class. Have a good night.